Today we are doing the quadratic formula, which is 4.7, and the learning goal, don't forget to write this in your notes, is I will be able to solve quadratic equations using the quadratic formula. So first I'm going to give you the quadratic formula again. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. The reason why I put the b squared minus 4ac in a different color is because this is called the discriminant. The discriminant is very important because it tells you, and I'll type it here, okay? It tells you the number of solutions you're going to have and the types. So if they ever ask you to find the discriminant, that's the part that from the formula that you use to help you. The way it works is if the discriminant is positive, that means that it's going to have two real solutions and it'll have two x-intercepts, which means it's going to it'll touch your, if you had to graph it, touch your x-axis in two places, whether up or down. Okay. If your discriminant is equal to 0, then it has one real solution. And one x-intercept. That means it'll only touch your graph in one place. And then if your discriminant is negative, then it has no real solutions. And it won't even touch the x-axis, so you'll have no x-intercepts. So that's why the discriminant is very important. Okay, when solving the quadratic formula, it shouldn't be that difficult. You just always want to make sure that your equation equals 0 before you even start. So for example, and it's good that we keep our leading coefficient positive. So I'm just going to move everything over. And what I do is I identify A, B, and C so that when I apply my formula, I'll have everything that I need. So according to the formula, it's x equals the opposite of b plus or minus, when you're plugging things in, square root of b squared minus 4ac all over 2 times a. And then from here it's just simplifying. So negative 1 squared is 1. Negative 4 times 2 times negative 4 is a positive 32 all over 4. And that'll make that 33. And so if you notice, we have two solutions. You could either write it like this, or you have 1 plus square root of 33 over 4, or 1 minus square root of 33 over 4. Those are your two solutions. And you can tell, and you know it's two solutions because our discriminant, which is the part under the square root, is positive. So that means that we should have had two solutions. Okay, we'll try one more. This one's already ready. So A is 2, B is negative 5, and C is negative 3. So X equals the opposite of B, plus or minus square root B squared minus 4AC all over 2 times A. So simplifying that, we get 25 plus 8 times 3 is 24. And we get the square root of 49, which is a perfect square. So 5 plus or minus 7 over 4. So we're going to work out our two solutions since it came out to be a perfect square. 5 plus 7 divided by 4 is 3. And you got 5 minus 7, which is negative 2 over 4, which is negative 1/2. So sometimes they come out nicely, sometimes they won't. Okay, now we're going to look at some discriminant problems. And from the discriminant, we're going to determine the number of real solutions. And remember, the discriminant is just a part under the square root. So I have negative 2x squared minus 3x plus 5 equals 0. Alright, so A is negative 2, B is negative 3, and C is 5. So applying my formula, it's B squared minus 4AC. It is very important that you put your values in parentheses so you won't mess anything up. So you're going to get 9 plus 40 equals 49. So since it is positive, that means you're going to get 2 real solutions, which means it's going to have 2 x-intercepts. Okay? Now you can try this one. 2x squared minus 3x plus 7 equals 0. So try this one and then we'll check our answer. Okay, A was 2, B was negative 3, C was 7. Plugging everything into my formula, I get 9 minus 56, which is negative 47. Since my discriminant is negative, there's no real solutions, which means it has no x-intercepts. And basically that's it.